Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. I hope all of you are doing very well. So today we are gonna start solving tutorial sheet number 3, which is part of high voltage engineering. So before I start solving the problems, I hope all of you having a small note and the calculator. The small note, if you have any question, any doubt, any misunderstanding in any part of the questions that I will solve today. I hope to write it down, and in the end of this session I will give you time to ask your question. Okay, and the calculator, as usual, I want you to practice doing calculation. So let's start with the question 1. So this week I will explain question 1, 2, 3 and 4 from this tutorial. And next week we will complete question 5, 6 and 7. So let's start with question 1. Classify the different electrical insulating materials and give example for each type. So the first part of the question, he wants us to classify the different electrical insulating materials. And the second part of this question, he asks us, a free electron in gas insulator is subjected to uniform electrical field. It is accelerated by 0.5 joule. If the electron velocity is proportional to the electrical field intensity, the proportional constant equals 2.1 into 10 to the power 9. So he wants us to calculate the electric field intensity and the corresponding applied voltage for 2 centimeter distance. So the electron mass equals 9.1 into 10 to the power minus 31 kilogram. So here in this question, he gives us so many values, and he asks us to calculate the electrical field intensity and the corresponding applied voltage. So let's move on to the answer sheet and see how can we solve this problem. Okay, in first part, he asks us about the different electrical insulating materials. So the different electrical insulating materials, we have 3 types, which is the first one is a gas, and the example for the gas air or SFX, which is sulfur hexafluoride. Okay, you can Google it and you can Google this to get a full knowledge about this gas, which is SF6. The second material is the liquid. We always use oil, and the solid, which is a glass, rubber, paper, and PVC, which is a cable type of cable. Okay, so the first part of this question, we have done this the first part, so it's simple, easy. First part, so the different electrical material insulating is gas, liquid, and solid, and we give some examples here. So let's move on to the second required from this question and to see the giving value in this question. Second part of this question, he give us a kinetic energy. We will give the kinetic energy the symbol as Ke, which is equal 0.5 joule, and the mass, which is M, it's equal 9.1 into 10 to the power minus 31. Also, he gives us the proportional constant, which we will call it as a K. It's equal 2.1 into 10 to the power 9, and the distance we will call it as a D, which will be equal to centimeter. If we want to change it to a meter, it will be 0.02 meter. So the required in this question. In this question, he asks us to calculate the electrical field intensity and the second required applied voltage. So the formula of the kinetic energy, Ke, it's equal 1 divided by 2 into mass into the velocity square. So here we don't have the velocity square. Why we need to find the velocity? Because in the first require the electric field formula, we have to find the velocity to find the electrical field that we called E. Okay, so we have to find the velocity to solve this problem. By using this formula here, Ke, it's equal half m into velocity square. So Ke is giving in the question, the kinetic energy it's giving in the question as 0.5 joule, and this is 1 divided by 2, and the mass is giving in the question as 9.1 into 10 to the power minus 31. All of this are multiplying by velocity square. Okay, so how can we solve these problems? So by using the divider, by dividing both sides by half into 9.1 into 10 to the power minus 31, we will get the formula as this. It will be look like this. So why we divide the both sides by this here? Because we want to remove the velocity side, the value in the velocity side, we have to remove it to make it easy for us to find the value of the velocity. Okay, so the velocity square, V square, it will be equal the kinetic energy, which is 0.5 divided by 1.2 into the mass, which is 9.1 into 10 to the power minus 31. If you use your calculator, you will get this value here as 1.094 into 10 to the power 30. Okay, so because here of square, we have to use the root to remove. We have to use the root here to remove the square on the velocity to get the value of the velocity, not velocity square. So the velocity will be equal root 1.098 into 10 to the power 30. We will get the answer as 1.048 into 10 to the power 15. So the velocity is 1.048 into 10 to the power 15. Now, since we already get the value, we already calculate the value of the velocity, so we can move on to the first required on this question. So what is the first required in this question is the electric field intensity, which we called it E. So from this formula, velocity it will be equal K into E. So we can find E here. This is the velocity, and this is the proportional constant, and this the electrical field. So here this is the required to find. So we have the value of the proportional constant, and we have the value of the velocity. So by playing with this formula, the formula will be look like E, it's equal velocity divided by K, which is proportional constant. So we have the value for the velocity, so we have to substitute the value here, and we have the value of the proportional constant, and we have to substitute it here. So by substituting the value of the velocity and proportional constant, we will get the answer as 400,000, 99, and 183. So we will make it near to 500,000 volts divided by meter. Okay, so it will be the electric field intensity. It will be 500 kilovolts divided by meter. Okay, so let's move on now to the second required, which is to find applied voltage. So from this formula, we can find the applied voltage. So the applied voltage, is equal E into D. E, which is electric field intensity, and D is the distance, which is diameter. The distance, sorry, which we called it D. Okay, so the electric field we just calculated, and we get the answer as 500 kilovolts divided by kilovolts into meter, and the diameter, the distance, which is D, it's equal to centimeter, and we will change it to meter here because we want to move the meter here. So it will be 0.02 meter. So V will be equal 500 kilovolt divided by meter into 0.02 meter. So this meter will go with this meter, so we will delete this with this, and the answer will be 500 kilovolt into 0.02, and the applied volt, if you use your calculator, you will get the answer as 10 kilovolt. So this is the question number 1. So we have done question number 1, and if you have any doubt in question number 1, just write it. Write your doubt on the note that you have, and in the end of this session, I will try to answer all your questions. Okay. So let's move on to the second question. The second question. He asked us to consider 500 into 10 to the power 6 is the number of electrons in 2 centimeter anode cathode space to break down the air. So the number of electron on the breakdown. Okay, provide that in air at giving field, the values of ionization and photoionization and attachment coefficient are. So this is here the ionization, which will called it as alpha here will be equal 7, and mu, which will be the photoionization, at which will be equal 4.5, and this is the attachment, which will be called it as N, will be equal to 0.2 respectively. So he gives us this value, the value of the number of breakdown electrons, and the distance, which is 2 centimeter, and the ionization, photoionization, and the attachment coefficient. He wants us to find the initial number of electron, to start the breakdown avalanche. Okay, let's move on the question part and see how can we solve this problem. Okay, let's move on to the second question. So the giving value in this question, he gives us the number of electron in the breakdown, and we will call it NBD, which will be equal 500 into 10 to the power 6. And the distance, which we will call it D, will be equal 2 centimeter. The ionization, which we'll call it as this symbol, will be equal 7, and photoionization will be as mu, will be equal 4.5, and the attachment coefficient, we will call it as this, and equal 2.2. So the required is to find the initial number of the electrons in O. We will call it NO. Okay. So from this equation, NBD will be equal NO. As I said, this is the initial number. E to the power net ionization into distance. So this symbol here for the net ionization. So from this equation, we can play with this equation and we will get the equation as a NO, it's equal NBD divided by e to the power net ionization into distance. Okay, so we have to find the value of the net ionization coefficient. We will call it as this symbol. So it will be equal the ionization plus photoionization minus the attachment coefficient. So the value of the ionization is 7. The value of the photoionization coefficient is 4.5, and the value of attachment is 2.2. So if you use your calculator, you can do it without using your calculator. But if you use your calculator, you will get this answer as 9.3. So now, since we get the net ionization, the value of net ionization, we can use this formula here because we have all the value here. So MBD, we have the value of MBD. E divided e to the power net ionization, we have the net ionization value, and we have the distance value. So by substituting the value in this equation here, we will get the answer as a 4.179 electrons. Okay, so this is we just finished question number 2. So let's move on to the question number 3. So in this question, we only need to find the net ionization and only substitute the value in this formula. So we have to know the basic formula to solve this question. So now let's move on to the question number 3. So to start the breakdown avalanche in uniform electric field with 0.75 centimeter distance, number of electrons was 400 electrons, and to get complete breakdown, the number of electron was 800 into 10 to the power 8 electrons. So NBD is 800 into 10 to the power 8. And the number of electron in O will be 400, and the distance will be 0.75. He wants us here to calculate the net ionization coefficient, and the second require if the ionization and photoionization coefficient are 9 and 5 respectively, calculate the attachment coefficient. So let's move on to the answer sheet to see how can we solve these problems. Okay, so as I said, everything in any question I have to write the giving value, the distance, which is d equals 0.75 centimeter, and the initial number is 400 electrons, and then NBD is 800 into 10 to the power 8, and ionization coefficient it's 9, and the photoionization coefficient is 5. So the first required, he wants us to calculate the net ionization coefficient. So from this formula, MBD it's equal NO, it's to e to the power net ionization into the distance. We can find the net ionization. Okay, so if you we have to substitute the value of the number of electron and the breakdown situation. So 800 into 10 to the power 8, it's equal the number of initial electron is 400 into e to the power to the distance is 0.75, and the net ionization is this value. This is what we want to find. So to remove the 400 from in front of e, so we will divide the both side by 400. So when we divide both sides by 400, we will remove the 400 here in this place. So 800 into 10 to the power 8 divided by 400 equal 400 divided by 400 into e to the power 0.75 into net ionization. Okay, so after after this part, after we divide the both sides by 400, it will be the first side will be 2 into 10 to the power 8 equal e to the power 0.75 net ionization. Okay, so to find the solution and to remove e from this equation, we have to use len. To use len, that's because we have a unknown value in the power. So there, this here is unknown value. So we have to use len because if you have any value in the power, any unknown value in the power, you have to use len to find it. Okay, so the both side len into 2 to 10 to the power 8, it's equal len e to the power 0.75 into net ionization. So by using len here, so when you use len here, you don't have to include the net ionization. You have to use in your calculator, you have to use len e to the power 0.75 to get the value. If you get the value, it's okay. So the value, it will be 0.75 if you use your calculator to net ionization. Okay, and if you use in this side len into 10 into 2 to the power 8, it will be as 19.1138. So if you get this value here, so easy way you can get the value of the net ionization. So the net ionization here, after we find the value, after we using len to the both side to find the because we have the unknown value in the power, so we will get the equation like this here. Okay, so the net ionization, it will be equal 19.1138 divided by 0.75. So if you use your calculator, you will get the answer as 25.5. Okay, so now we just finished the first required in this question. Let's move on to the second required in this question. So the second required in this question, he asked us to calculate the attachment coefficient. Okay, so from this formula we get it before. The net ionization is equal ionization plus photoionization minus attachment coefficient. So by playing with this formula, we will get the formula as this here. So the attachment coefficient will be equal the net ionization minus photoionization. So the value of net ionization is 25.5, and the value of the ionization is 9, and the value of the photoionization is 5. So by calculating this, you will get the answer as 11.5. So this is what we have to do in this question. So we solve question 3 part 2. It's easy, as you can see. We only need to know the formula and playing with the formula. Okay, so now if you have any doubt, just write it down in your note, and in the end of this session I will give you time to ask your question. So now let's move on to the last question today, which is question number 4. So for question number 4, for secondary ionization, here he give us secondary ionization. For secondary ionization coefficient of 2 into 10 to the power minus 8 and net ionization coefficient of 6.2, find the initial number of electrons to initiate avalanche. Okay, consider space 1.3, the distance, centimeter, between anode and cathode, and number of breakdown electron is 180 into 10 to the power 7 electrons. So we have so many giving value, and he wants us to find the initial number of electrons. The initial number of electron, we called it N0 or N epsilon. Okay, so let's move on to the answer sheet to see how can we solve these problems. So the giving value, as I said, the secondary ionization coefficient, we will call it as a gamma, will be equal to 10 to the power minus 8, and the net ionization coefficient, which we will call it alpha with dash, will be equal 6.2, and the distance, we will call it d, will be equal 1.3 centimeter, and the number of electron in the breakdown situation will be 180 into 10 to the power 7 electrons. So the required is find the initial number of electron, which we called it N epsilon. So with the secondary ionization coefficient, the formula for the NBD is this. The formula for the number of electron in the breakdown situation will be like this. N breakdown equal N initial into e to the power net ionization to the distance divided by 1 minus the secondary ionization, open the bracket, e to the power net ionization into distance minus 1, and close the bracket. So from this equation, from this formula above, we can find the required of NO. So by playing with this formula, the formula to find the number of initial electron, we have to use this, play with this formula. So when we play with this formula, the formula will be NO equal NBD, open the bracket, 1 minus gamma into e to the power net ionization into distance minus 1, close the bracket, and this will be divided by e to the net ionization into the distance. So by dividing the both side here, by dividing the both side by this value here, so we divide the first side here to remove the whole side. I didn't write this in the answer sheet because it will be long. So we move this side from N initial number, and NBD will be like this. So by playing with this formula here, the formula will be like this. So when we get this formula here, we need to substitute the value for NBD, which is the number of electron in the breakdown situation, which is 180 into 10 to the power 7, and gamma here, which is the secondary ionization, 2 into 10 to the power minus 8, and the e to the power, the net ionization is 6.2, and the distance is 1.3, and also the same thing in the here. So if you use your calculator, you have to substitute only the value in this formula here. If you substitute the value in this formula and doing your calculation, you will get the answer as 568,632.26 electrons. And to make it better, the number of initial electron, it's equal 56 into 10 to the power 4 electrons. And this all for today. So if you have any question, any doubt in any part, in any question, you can ask me now, and next week inshallah we will complete tutorial number 3. Thank you guys, and have a nice day.